Here we're going to find the sum of the following set of numbers. We have 9 plus 11 plus 13 plus an unknown quantity of numbers up to 73. And what I want you to notice about this sum, this sequence of numbers here that we're adding together is they have all a common difference. So 9 plus 2 is 11, and 11 plus 2 is 13. And the dot, dot, dot means we can assume that it continues in the same manner for the rest of the terms. So what I notice is this is what we would call an arithmetic sum, which means that all of the terms have a common difference, which we usually use the letter D for the common difference. So to find that D, we would go 11 minus 9 is 2, which is the same as 13 minus 11, which is also 2. So the common difference D in this case is 2. And if you remember from your arithmetic sum work, the formula for the sum of an arithmetic sequence is n divided by 2, so the number of terms divided by 2 times the quantity of the first term added to the last term. Cool. Now there's a lot of pieces in this that we know. We know the first term is 9. We know the last term is 73. We just don't know how many terms are here because of the dot, dot, dot in the middle. So the big step is that we need to find D. No, we need to find, not D, we know D. We need to find N. Okay, the way we're going to do that is we're going to use the formula for A sub n for an arithmetic sequence, and that is given by A sub 1 plus n minus 1 times D. If you want to see justification for that formula, check out my previous video on arithmetic sequences and arithmetic sums. Okay, so in this case, we know D is 2. We know A1, that's awesome, A1 is 9. So we have AN equals 9 plus n minus 1 times 2. Or rewriting that, A sub n equals 9 plus 2n minus 2. A sub n equals 2n plus 7. Cool. Now here's how we can use this to find n. We're going to use, let's see, our A sub n, our last term, and figure out which term that is. So we're going to pick A sub n is 73, and then find which n makes that true. Okay, so we have A sub n equals 2n plus 7. A sub n is 73. We want to figure out what term is 73, so 2n plus 7. Oh, cool. Pretty easy equation to solve. Subtracting 7 from both sides gives us what? 66 equals 2n. So that must be the 33rd term. Cool. Okay. We know n. We know A1. We know AN. We can now plug it into that green formula right there. So n is 33 terms divided by 2 times the quantity. A1, our first term is 9, plus our last term is 73. And now we just have some calculations to do here. Let's see. So 9 plus 73 is 82. Let's move down here. S equals 33 over 2 times 82. Let's see, that's like an 82 over 1. So I can reduce the 2 and the 82 to be a 41 and a 1. Now I just need to multiply 33 by 41. And 33 times 41 is 1,353. So if we add up all of these terms together, we must get 1,353. So just to recap real quickly, in order to find an arithmetic sum, you need to figure out the pieces of this formula here. S equals the number of terms divided by 2 times the quantity first term plus last term. If the question is written like this, you already know your first term and your last term. You really just need to find n. And in order to find n, the number of terms, you generally need to figure out the formula for a sub n so that you can plug in your last term and figure out how many terms got you there. Once you have all those pieces, you can plug them into your formula for the arithmetic sum, and you should be able to figure out what that sum is.